Hi, I am Godji, and welcome to my session. I'm a software engineer, 3. I've been working with the HPCC Systems Platform team for the last 6 years. And for the last 4 years, I've been working on cloud infrastructure. And currently, I'm working on testing the containerized HPCC Systems Platform cloud features. Over the last few years, it has become increasingly easier to deploy the HPCC containerized platform by using cutting-edge automation tools like Terraform, GitHub Actions, and so forth. With the combination of tools, services, and processes like Kubernetes, cloud like Azure, and automation, what used to take us weeks or months now take us minutes. However, one thing remains a challenge for many users. It is how to secure the HPCC platform and the cloud. It sounds complex and intimidating. In fact, it is. But thanks to infrastructure like Terraform, we are able to share with you our configuration for an easy replication. Over the course of this presentation, we will teach you how to secure your containerized HPCC environment in the cloud using basic authentication. And at the end of this presentation, you should be able to successfully secure your containerized HPCC systems platform in the cloud using htpasswd and TLS. So our objectives today is twofold. First, how to secure your containerized HPCC system platform using htpasswd. And second, how to secure your data during transport using transport layer security or TLS. To secure your ECL watch using htpasswd, we will go over how to implement that, how to add users, how to delete users, and other upcoming features that we are working on as well. For TLS, we will show you how to configure TLS using Set Manager, how to enable TLS for HPCC Systems Platform using self-signed certificates. So let's start with securing our environment using htpasswd. So what is htpasswd? htpasswd is a basic security manager for HTTP clients that stores usernames and passwords as hash. So it takes the password and hash it with a cryptographic algorithm and store that data into a file that is called the htpasswd file. Or in another case, you can also use a data store like DBM Manage to store that data as well. So what do we secure when you use htpasswd for HPCC Systems Platform? For HPC systems, htpasswd can be used to secure a CL watch currently. But in the near future, we would like to secure ECL queries and other web-facing services as well. Here, we're looking at some of the supported features that we have. You can add users by defining them. You can add new users from an existing htpasswd file. Let's say you have an existing htpasswd file that you've been using for a different environment, and you would like to use that list of users with your new environment. You can import that place as part of your Terraform configuration. Also, we will show you how to remove users, how to restrict authorization based on services. That is a feature that is common, and it will only be available for users defined and the users.auto.cfs file. And last, allow authentications for specific users for a specific number of days. Let's say you want the user to only have access to the cluster for an amount of 30 days. So after 30 days, when you do an apply, a Terraform apply, the user will no longer have access to that cluster. To configure htpasswd, there are two different methods that we can use. The first one is by using Kubernetes secret. And the second one is by using a storage blob. Let's go back to the first one, the Kubernetes secret. This one is our preferred option for one reason, because it is more secure than the last one. But the disadvantage is that it requires a little bit more knowledge to configure. As for the storage blob, it requires a little bit less knowledge, but also less secure. And for this presentation and in our Terraform implementation, we use the Kubernetes secret method. So how to configure the htpasswd for HPCC platform using a Kubernetes secret? First, we will add new users. We will create a Kubernetes secret, and then we will configure the secret section in the values.yaml with the proper secret names. After that, we will supply the authentz config to the Helm deployment. So what we're looking at right now is how we add new users. First, you can see that we have a list of objects, and each of the objects is represent a user. We have first name, last name, we have email, we have username, we have password, we have expire end days, which is the amount of the number of days that the user will have access to the cluster. And we have a purpose. We have a purpose as well, a purpose section where you can leave comments on that specific user. And we also have secure services. For the secure services, it's a feature that we are working on where you can select which component that the user should have access to. For instance, currently you can have access to ACL Watch, but if you could have access to ACL queries, you could choose either for the user to have access to ACL Watch and ECL queries, or just ECL Watch, or just ECL queries. So how to configure htpasswd for HPCC systems? When you want to remove a user, how do you do that? To remove a user, there are different ways you can do it, and some of them depends on how you added the user in the first place. In the case where you define the user, you can just open the users.auto.cfs file and remove the config for that user from that file. So you'll basically remove the object for that user or comment it out, and that will remove the user the next time you do a Terraform apply. Another way you can remove a user is by the use of, if you are using an existing htpasswd file, is first by opening the htpasswd file with a text editor like code or something else, and delete that line of data for that user. So that includes the username and password. And the last option, which is the best option, is to use the htpasswd client tool to do that. that client tool has a specific feature where you can remove users from the user list. So another way you can add new users is by using an existing htpasswd file. Like I mentioned earlier, if you happen to have an htpasswd file with a list of users that you want to import for your environment, you want to import it as part of your user list, you can do that by setting the htpasswd file path against the htpasswd_file variables. And that will import the existing user list into the list that you defined as one big list of users for your environment. So here what we're looking at is how we actually first set the credentials for each user and how we encrypt the password as well. Here we're using Bcrypt. Bcrypt is a cryptographic algorithm that HTTP uses, and it is the most secure one that you can use. So we're using Bcrypt to encrypt the password before we feed it to the Kubernetes secret. On the left, you will have the username, and on the right of the column, you will have the encrypted password. Here we have an example of the Kubernetes secret that we create. As you can see, we feed the data from the user list. We feed the encrypted password and username to the secret. And here we set the secret name and the values that came on file and to tell HPCC what secret we want to use. So right now we're using a secret for ESP. So we are securing its ECL watch. And here we are configuring the OpenZ to secure ECL watch. So basically what that does is it's telling HPCC what the security manager that should be used, and as well as where to find the htpasswd file on the pad. So when we create the secret is mounted as a volume to the pad. For instance, here we have we're securing the ESP. So the secret will be mounted as a volume to the ECL watch pad, and the username and passwords will be made available to that specific pad only. And that's what we're saying to HPCC. We're telling it how to find that file, the htpasswd file that is created from the volume. And we also have other things like description, lib name, and so forth. So far, we have covered how to secure the HPCC system platform using htpasswd. We've shown you how we encrypt the user password using Bcrypt encryption, how we feed the encrypted data to a Kubernetes secret, how we mount the secret as a volume to ESP. The secret data is safely made available to the ECL watch pad, how we configure the OpenZ to secure the cluster using the secret data, and also how to add users, remove users, and how to use an existing htpasswd file. Now let's talk about TLS. So our objective with TLS is to show you how to secure your data during transport using transport layer security, or TLS. We will show you how to configure the TLS using Set Manager, how to enable TLS for HPCC Systems Platform using self-signed certificates. First, what is TLS? TLS is a cryptographic protocol. It secures data during transport over the internet. It uses encryption algorithms to scramble data and make it unreadable to bad actors or anyone who might intercept it. It also protects data from being tampered with during transmission or transport. And it provides identity verification to ensure you are communicating to the intended party or application or website. So what is Set Manager? Set Manager is basically a Kubernetes controller. By that, I mean, it monitors, it compares, and corrects discrepancies that have to do with the certificates. It automates the process of obtaining, renewing, and managing TLS certificates. It issues certificates from certificate authorities like Zero SSL, LexisNexis, HashiCorp Vault, and even your private PKI, etc. And it also handles the entire lifecycle of certificates, including creation, automated renewal, and deletion. Before we go any further, we should also know what a self-certificate is. A self-certificate is a digital certificate. It is created, signed, and verified by the same entity. And that's where the name comes from. And the same entity verifies its own identity. It is not issued by a third-party certificate authority like Zero SSL or LexisNexis. It is not trusted by browsers. App or website might be flagged as unsafe to users. So when you visit a website or an application that uses self-signed certificates, you will likely be warned that this website or application is not safe. And that's when you know, even though you see the HTTPS in front of the address, that's how you know that this application or website is using self-signed certificates. And it is not to be used where data security is important. For instance, if you are concerned about your data being leaked or being intercepted during transport, you should not be using self-signed certificates. You should instead use a public issuer like Zero SSL or LexisNexis or something else like HashiCorp Vault or a private PKI. How to configure Set Manager? To start, we will add the JetStack Helm repo. For this demo, we will not be using Terraform. We will show you how to do it using CLI. And from there, you can implement that in Terraform if you would like. So here we are adding the repo as part of our Helm repo list. We want Helm repo add JetStack, which is the name of the repo, and then followed by the address of the chart. And if we do Helm repo list, we should see it as part of our list. Here we go. And next, we will install Set Manager The set manager here is going to be a chart that we are going to install with Helm. So we're going to do Helm install set manager, which is the name of the release, and then followed by the path to the chart, and then the version. So if we do Helm list, we can see that set manager has been deployed. Next, we are going to generate root certificates for local cluster certificate authority, as well as a private key. So for that, we are going to use to go to the Helm directory inside the HPCC platform package. And then we are going to use the OpenSSL command or tool to generate that certificate and key as a single command. As you can see, we didn't have a certificate or private key before. And if we do an ls here, we now have a certificate and a private key. And that is for the local certificate. Next, we will create a Kubernetes secret from the generated certificate and private key. So we're going to run kubectl create secret TLS, which is the type of secret that we want to create, followed by the name of the secret, which is HPCC local issuer key pair. And then we're going to feed the certificate and the private key to that secret. Here we have created the secret, as you can see. And next, we are going to generate the sign-in with certificates now. So we're going to do the same thing, but for the sign-in with certificates instead of local. We are going to use the OpenSSL command again to create that certificate and private key in a single command. So right now we have our sign-in certificates and private key. Next, we are going to create a Kubernetes secret, the same thing that we've done earlier. But this time we are going to do it for the sign-in certificate and the private key. We're going to run kubectl again. So kubectl create secret TLS, and then followed by the name of our secret. But first, let's show you what secrets we currently have. So as you can see, we do not have a sign-in a secret for the sign-in certificate. And now we've run the command. As you can see, now we have a secret for the sign-in issuer. And next, we are going to enable TLS for HPCC Systems Platform. And that is a simple process. All we have to do is to set the certificate that enable inside the values.yaml file to true, and that will enable TLS for HPCC platform. And I should also mention that we are using everything that we are using by default. So even the name of the Kubernetes secrets are default names. So those names, you will find them in the default values.yaml file. So that's why we didn't have to change anything. We use the same name. And I should also mention that the secret name that we use should reflect the same name that is in the values.yaml file under the certificate section. So we're gonna go ahead and enable TLS. So since we already have the cluster one in, we're just going to do an upgrade. So we're going to run Helm upgrade, followed by the name of the cluster, and then the name of the chart. And then we are going to use the user values, the user provided values that we currently have on our cluster configuration. And then we will set the certificates that enabled to true. And that will enable TLS for HPCC platform. So in summary, we have shown you how to secure your data during transport using transport layer security, or TLS, which is a cryptographic protocol. We've learned about Set Manager, which is a Kubernetes controller for certificates. We've shown you how to configure TLS using Set Manager. We've also learned about self-signed certificates, which are created, signed, and verified by the same entity. And last, we have shown you how to enable TLS for HPCC System Platform using self-signed certificates. Earlier on, we went over how to secure HPCC Systems Platform by using htpasswd. We've shown you how to encrypt the user, how we encrypt the password using bcrypt encryption, how we feed the encrypted data to a Kubernetes secret, how the secret is mounted as a volume to the ESP pad, how the secret data is safely made available to the ECR watchpad, how we configure OpenZ to secure the cluster using the secret data, and also how to add users, how to remove users, and how to use an existing htpasswd file. Here we have some reference for you if you'd like to go through them. We have a reference for htpasswd from the Apache documentation. We also have a reference to DBM manage, which we haven't used yet. And if you'd like, you can go through that as well. And that is from Apache. We have linked to Terraform. We have reference to Kubernetes secrets, if you'd like to learn more. And also, we have a README on TLS, how to configure it, how to enable it for HPCC platform on our HPCC platform repo on the HPCC Systems account, GitHub account. So I would like to thank you all for attending my session. And if you'd like to take a look at my GitHub repo, you can do so by going to github.com/gfortil. Or you can, if you feel like you should contact me directly, you can do so by sending me an email to godji.fortil@lexisnexisrisk.com. Once again, thank you and have a good day.